In this session, we're going to discuss solving factorable equations. Solving factorable equations. Alright. And we'll start off with a trinomial that looks like this. Let's see. 7x squared plus 33x, 7x squared plus 33x minus 10 equals 0. Alright, so if I just took off the equals 0 part, this would be just like the problems that you would have dealt with in the section on factoring trinomials. So this is no different. Alright, we have a trinomial here and we see that it's a quadratic. The way we know it's a quadratic, let me put that out here. This is a quadratic, okay? And the reason being is because the highest degree for this polynomial is 2. So alright, so this is a second degree polynomial. In other words, the exponent is squared, and that's the highest exponent. So this trinomial is considered a second degree trinomial, which makes it quadratic. Alright? Now, because this is an equation now, because we have an equal sign, we have to go through the process of factoring if possible, but at the end of the day we have to make sure that we've solved for the unknowns in the problem. In this case, the unknowns are x, or the unknown is x, so we need to find out what x is. Well, when we have a quadratic, it's typically best to try to go ahead and get all of the terms on one side, as you can see here. If there's our equal sign, let's say our equal sign splits the problem up, we want all of the terms on one side of the equal sign and we want 0 to be on the other side. But again, that's when we're dealing with a quadratic, okay? Or for that matter, I would say at this point, any non-linear equation, we'd want to get all the terms on one side and the other side we want to set equal to 0. So this particular problem would already fit that form. So we go to look to do our reverse FOIL, still keep it set equal to 0. I know my first term, which is 7x squared, I can get that by saying a 7x times an x. That's the only way I can get 7x squared, is 7 times 1, or 7x times x. Alright, and 10 is either going to be 10 times 1. Alright, 10 can be found by multiplying 10 times 1, or 5 times 2. Well, I know I'm trying to get to a positive 33 with my outside and inside. Alright, so I know 7 times a 5 is a 35. That gets me close. So I want to multiply my 7 times 5 and my x times 2, and then subtract and say 35 minus 2. But I want my 35 to be positive because my middle term is positive. Because the middle term is positive, I want my 35 to be positive. And so I make my minus right here. So first and first is first, last and last is last. Outside gives me 35x. Inside gives me a negative 2x, and these combine to give you a positive 33x, okay, which is what you want right there. Alright, so everything checks out. Alright, just wanted to show that right quick as a quick review to what we learned when we were doing the factoring of trinomials. Okay, so now that I've factored, the problem is in this form, so I have my factors set equal to 0. So all I do now is set each factor that has a variable in it equal to 0. And here I get 7x equals 2. 5 by 7 divided by 7. X equals 2 over 7 minus 5 minus 5. X equals negative 5. So these would be my two solutions. And it was hinted that I have two solutions because it's a quadratic, because my degree for this trinomial is 2. So because the highest exponent is 2, that suggested that there may be 2 solutions to the problem. Alright? So now, let's look at a problem like, let's see, like this. So we have 3x minus 1, and we have 5x plus 2 set equal to 0. Alright? Now, your instincts may tell you when you see this problem that this is a binomial, and that you want to multiply these two binomials. But remember, we're trying to solve by factoring if at all possible. So factoring means I'm trying to undo multiplication. So I don't want to multiply to turn around and have to undo the multiplication by factoring. What you need to recognize is that these are the actual factors set equal to 0, so you're already at a point where you're ready to solve for x, because this stage here is equivalent to being at this stage here. Notice, you had a trinomial here, and you factored it to these two binomials. Alright, it had them set equal to 0, and then you just set each of the two factors equal to 0 and solve. So because these two binomials are already set to equal 0, then at this point all I need to do is take each one of them, set them equal to 0 and solve. Alright, minus 2 plus 1 plus 1. So I have 3x equals 1, 5x equals negative 2, divide by 5, x equals a negative 2/5, divide by 3 over here, x equals 1/3. So these would be my solutions. Alright, and again, I didn't need to multiply this because it was set equal to 0. Alright, because it was set equal to 0, all I needed to do was just take each of the binomials and set them equal to 0. This binomial equal to 0, this binomial equals 0, and then solve for the x's. Alright, now there's a difference between this problem and this problem here. Let's see, I want to say x plus 1, x plus 2, and it'd be equal to 42. Alright, now this problem, you may say, is similar to this problem, so you want to just say x plus 1 equals 0 and x plus 2 equals 0. Alright, but the difference between these two problems is right here. This problem equals 0, this problem equals 42. So at this point, now because this is not equal to 0, now I have to multiply over here on this side. Alright, I need to work this side out, then bring this over. So we'll do the work, we'll do FOIL, so first and first will give me that. Outside, which is this, 2x. Inside, which is that, 1x, 2x, and 1x is 3x. And then last and last is plus 2. Alright, so I have x squared plus 3x plus 2 when I multiply these two binomials equal to 42. Alright, and we explained over here that when you have a quadratic, again hinted by the square, that you want all the terms on the same side of the equal sign, and you want them set equal to 0. So I need to move this 42 over here. So I subtract 42, that cancels. So now I have x squared plus 3x, and this gives me what, a minus 40 now. And on the other side of the equal sign, now because these cancel, now I have 0, because the 42 and the negative 42 canceled each other out and left 0. Now I have a quadratic set equal to 0. Okay, a quadratic set equal to 0. So I can factor this by reverse FOIL, and now put it in the form that it would look like this. A binomial equals 0. A binomial is going to go here, binomial is going to go there, equal to 0. So x is going to be from x squared, it's going to come from x and x. 40 is 8 times 5, which will get me to a 3. Since it's a positive 3, I want the 8 to be positive. So a positive 8, negative 5, first and first gives me that, last and last gives me that. Outside is a positive 8, inside is a negative 5. 8x minus 5x is a positive 3x. Now I have my factors. So now this part again looks like this part. So all I do is take each factor, set it equal to 0. So x minus 5 equals 0. You'll get x equals 5. And then you have x plus 8 equals 0. You get x equals negative 8. So your solution, 5 and negative 8. Alright. So I wanted to make sure you're paying attention to certain similarities and differences. Okay. And then the last problem, one last problem. I'll go ahead and erase all of this stuff and just write a clean slate. Let's see. So for the last problem, we want to say n times 2n plus 4 equals 96. Alright. Now, again, you want 0 over here, so the fact that this is a 96 tells me that I need to go ahead and do whatever operation I see on the other side. So over here I see multiplication, so I'm going to do it. If this was a 0, okay, if that was a 0, then I would just go ahead and set n equal to 0 and 2n plus 4 equal to 0 and solve. But because this is not a 0 right here, I do the multiplication that's being required on this side of the problem. So I end up with 2n squared plus 4n equals 96. Alright. And then from there, let's see, I need to move the 96 over, because again, this is quadratic, and quadratic says I want everything on one side of the equal sign and I want 0 on the other side. So that's going to cancel and give me my 0. So now I have 2n squared plus 4n minus 96 equal to 0. I couldn't combine these because they weren't like terms. That's why I wrote them out right here. Alright. Now, before I get the factoring, because it's in the form, it's quadratic equal to 0, so it's in the form that I want. Alright. But what I notice is that all of my coefficients are even. So I can pull a 2 out. So if I factor a 2 out, I'm left with an n squared plus a 2n minus, what is this, 48 equal to 0. Alright. So I keep my 2 on the outside. And now I'm going to use reverse FOIL on this. So that's going to be an n and an n. And 48 is 6 and 8. Trying to get to a positive 2. So I want my 8 to be positive. So I make my 6 negative. First and first is first. Last and last is last. Outside is a negative 6. Inside is a positive 8. 8n minus 6n is a positive 2n. So this all checks out. And now I go to solve for my factors. Alright, this 2 doesn't mean anything because it doesn't have a factor attached to it. So really, all I'm doing is dividing both sides by the 2. That will cause the 2's to cancel over here. And 0 over 2 is just 0. So I have n plus 8 times n minus 6. 0 over 2, which is just 0. And so I say n plus 8 equals 0. N minus 6 equals 0. Minus 8 minus 8. N equals negative 8. Plus 6 plus 6. N equals 6. Alright. So there you have it. So that pretty much takes care of, I guess, the more common situations that you'll be faced with when it comes to trying to solve equations that will involve some form of factoring. In this particular problem, one of the common mistakes we make is we forget that we should always look to factor out something first, if at all possible. Alright, so we should always be checking a problem or an expression to see if we can factor out whether it be a common variable or a common coefficient. We should always be looking to factor something out first. Now if we can't, then so be it, we don't. But if we can, we want to always do that first, because we see it makes the problem a little bit easier to deal with. I had this. When I factored the 2 out, I got this. And I would venture most of y'all say it's easier to factor that than it would be to figure out the factors for that trinomial. Alright, so at this time we're going to conclude our session, and as always, feel free to contact me if you have any questions. Thank you.